The 20th century was built by tearing power directly out of the earth. It was a process of violent, singular extraction. Those extracted molecules held the chemical energy density required to move thousands of tons of cargo across oceans. This subterranean energy was the prerequisite for the modern global supply chain. It also enabled the era of commercial flight. Only the concentrated energy of liquid hydrocarbons could lift 100 tons of steel and passengers into the sky. For 100 years, economic and geopolitical strength was often determined by a nation's geographical luck, whether or not they sat on top of an ancient carbon reserve. We are now attempting to stop that extraction, but we face a massive energy gap. As this chart shows, the sheer weight of batteries required to power a cargo ship or a long-haul jet makes them physically impossible for heavy industry. The density gap is a matter of physics. Aviation and heavy manufacturing require the molecular structure of a hydrocarbon. Electricity alone cannot provide the necessary force. We require the chemical density of a hydrocarbon to keep the world's heavy infrastructure moving, but the carbon within it can no longer come from beneath our feet. The solution, therefore, is to transition from extracting ancient carbon to manufacturing new carbon molecules above the surface. This can be done by taking the standard chemistry of combustion, burning fuel for energy, and running it in reverse. It begins with massive amounts of renewable electricity from wind and solar farms, which serves as the raw energy source for the process. Next, carbon dioxide is captured directly from the atmosphere or from industrial exhaust. That clean electricity is then used to crack water apart, isolating pure green hydrogen. When that captured carbon and hydrogen are forced together under extreme conditions, they forge a synthetic fuel. The result is a molecule identical to the oil we used to drill for. We are now able to manufacture fuel out of air, water, and sunlight. Because this synthetic fuel is molecularly identical to petroleum, it functions as a drop-in solution for the world's existing machines. We do not need to rebuild every pipeline on the planet or invent entirely new jet engines. These wind and solar fields are essentially the manufacturing plants for a new molecular economy. A nation's ability to harvest these renewables now creates a strategic foundation for its heavy transport and global trade. Moving this chemistry from a laboratory to a global fuel supply requires scaling this production to an industrial level. Net Zero Green Bharat is working to commercialize this transition, building the industrial infrastructure to synthesize India's wind and sun into heavy-duty fuels. The pioneers who built the modern world look down into the earth for power. The ones who will sustain it are looking up.